Hi everyone. I want to make a short video to explain the differences between GetFile, ListFile, and FetchFile processors, why you should never use the GetFile processor, and how to properly use List and FetchFile processors. In this video, I'm focusing on GetFile, ListFile, and FetchFile, but the same would apply for other processors like GetX, ListX, and FetchX processors, like for S3, ADLS, Blob Storage, TCS, etc., SFTP, etc. For this demo, I'm using the file processors, but this would really apply to other integrations as well. So in this scenario, I imagine that I want to process files that are locally available to the NiFi nodes. So a very common use case we have is you have like an NFS storage that is attached to all of my nodes of my NiFi cluster, and I want NiFi to process those files and read those files from the NFS storage. So this is a very common use case, and when you drag and drop a processor, the first one you may want to use is GetFile. That would actually get the file from the local file system, and then you can use it for processing in your data flow. So that's really the example I have here. But this processor has been in NiFi since the very beginning, and since then we added much better options. So GetFile should actually be completely ignored and removed from your flows. The GetFile processor is a processor that will read the file locally to the NiFi node, and by default will delete the file once the file is ingested in NiFi. So if I open this processor and look into the configuration, you can see here that the default is keep source file false. So you need to be very careful with this, because if you make a mistake with the input directory where you are looking for files to ingest, you could actually delete very important files on your NiFi node. Also, by default, the recurse subdirectories is set to true, which is also something you need to be careful about, because if you change the input directory for something like / that could be bad. Obviously, the deletion of files is only if the NiFi user running the NiFi process is allowed to delete those files, but still this could be bad. Another thing with the GetFile processor, especially when you are running a NiFi cluster, is that the GetFile processor would run on only one node. You would have to configure the GetFile processor to run on the primary node only. So the primary node is just a node that has been elected within your cluster that gets this role of being primary. This is an abstraction in NiFi allowing you to configure some processors to run on a single node. This is very useful in this kind of pattern. So in this case, we want the GetFile to run on the primary node only, because if you have the GetFile running on all the NiFi nodes, and all of the NiFi nodes have the same attached NFS storage, then the GetFile running on all processors will concurrently access the same files, and that would create issues. So you will configure the GetFile to run on the primary node, but in the end, it means that only one node in your cluster will be actively processing data and doing actual retrieval of the file. So that's not really great if you have an NiFi cluster, because, well, all of the other nodes are going to sit there and do nothing. If I start the GetFile, so for this demo, I created folders that are available to all nodes, and in this folder, I added 1 million files. So this is also to explain how NiFi would behave in the case where the input directory is containing a crazy number of files that you want to fetch. This could happen because this is the first time you run the processors on a specific directory where you have a lot of files. Or it can be the case after NiFi has been stopped for a long time and you start NiFi again, and a lot of new files have been added because your sources are generating a lot of data. So it can happen for many reasons that when the processor is going to run, a lot of files are actually available for processing. So if I start the GetFile processor, this is going to look into this directory that I configured here, which is tmp demo get, and this is going to retrieve the files. Something that is important here is that we have this batch size 10. So what is happening is actually the GetFile processor is going to list all of the files available in that input directory and then generate one flow file per file listed. But it will fulfill the back pressure settings. So after GetFile retrieved 10,000 flow files, the processor will stop and will wait for back pressure to be to go off before getting additional files. So we can see here that we have 10,000 files that we retrieved, and that's it. By default, this is the setting for back pressure. So I will have to do actual processing on the files so that GetFile is retrieving additional data. So that's one thing. That's GetFile, but as I said, I highly discourage the use of the GetFile processor. Instead, you should use the ListFile and FetchFile processors that are working together. The reason why we did this, we have this concept of List+Fetch. This is a very common pattern in NiFi. This is a pattern that is allowing you to actually leverage all of the nodes in your NiFi cluster. So how is it working? The ListFile processor is going to be configured to run on the primary node only. And the only purpose of this processor is to do a listing and generate flow files containing the metadata of the files that have been listed. It won't retrieve the actual content of the data. It's just a listing. And then the fetch file will use the metadata of the flow files generated by the ListFile processor to actually fetch the data. The reason why it's great is that the ListFile is running on the primary node only. Then the fetch file is going to run on all nodes, and you can configure the connection between list and fetch file with round-robin load balancing. So in the configuration and the settings here, I can configure round-robin load balance strategy for my connection, which means that all of the flow files created by the list file that are only containing metadata information about the files that are available will be shuffled across all of the nodes of my cluster, and then fetch file will be running on all of the nodes. It means that in the end, after the fetch file processor, all of my files will be retrieved across the nodes of my cluster. So actually, if I list the queue here, we can see that all of the files that I retrieved are on the same node here, NiFi 1. So I have 3 nodes, NiFi 0, NiFi 1, NiFi 2. And we can see here that all of the files that I retrieved are only on NiFi 1. When I use this pattern, I will be retrieving the files on all nodes of my NiFi cluster. So if I have a lot of files to process, I can really leverage the power of having a NiFi cluster. So that's great. However, there is a small thing that is really important to note here, is that the ListFile processor is going to list all of the files that are available in the input directory that I configured here. And something that is important to keep in mind is that the list file processor by default will be looking at the timestamps of the files listed, so that the next time the list file processor is running, we would only list the new files that are made available. So this processor is keeping a state which contains information about what is the last file that I listed, so that at the next execution, I'm only looking at the new files since the last execution. If you don't want this behavior because you want to always list the same files again and again, you could use the no tracking strategy if you want. Also, something that is important to keep in mind is that the list file, if you have like one execution of the list file, and as I said, I have a crazy number of files that are available in my directory, it will create one flow file per listed file. So if you have a very large number of files, like this is the case here, I have 1 million files in my input directory, this will generate as many flow files as files that the processor listed. So if I start this, it's going to run for a while because it's listing all of the files, and it's going to actually generate 1 million flow files, which is really not great for NiFi. Having tons of flow files like this is putting a lot of pressure on NiFi memory, and this is not great because it means that at one given point in time, NiFi will have in memory all of this metadata information about all of the files that I listed. And since the 1 million flow files are being generated in the single execution of the processor is not able to account for the back pressure setting here. So even if I have a 10,000 back pressure setting for the number of flow files here, I will be actually generating 1 million flow file. So it's going to take a while, and I didn't try this before. So actually it could cause some issues with NiFi and the memory. I think I have enough memory, but that's not something great because, as I said, I will have all of the information in memory at some point. Keep in mind that it's not because you have like a lot of flow files here that everything is in memory. When you are going above some thresholds, we will be swapping this information so that we are not putting too much pressure on the memory of NiFi. However, since we are generating the 1 million flow files in the same iteration of ListFile, in this case, we have all of the information in memory, which is really bad. So obviously, most of the time, your use cases wouldn't list so many files for one single execution of the processor. But in this case, I imagine the situation where I can be in a position where a lot of files have been generated. So it's going to take a while here. I'm going to keep refreshing and wait for the data to be generated here between the two connections, between the two processors in the connection. But it could take a while to generate everything here. So I'm going to wait a bit. While it's running, I can actually go to the next flow definition, where we actually better manage this scenario where the list file could be listing a lot of files. So in that case, there is an option that has been added in NiFi releases, like maybe I would say 1 or 2 years ago, which is the option to configure a record writer. This is available on all ListX processors. And this option is very useful if you know that you may be in a situation where you are going to list a lot of files, because instead of generating one flow file per listed file, what the processor is going to do is to generate one single flow file, but the content is going to be an array of items describing all of the listed files, but it will be just one flow file. So instead of here generating one flow file per listed file, and the flow file would have no content, just attributes with the metadata of the listed files. In this case, we generate one flow file, and all of the metadata of the listed files is actually in the content of the flow file. So here we can see that we generated 1 million flow files, and now the load balancing is active. So it's actually shuffling the shuffling the data across my NiFi nodes right now. So we can see the listing took 4 minutes and 12 seconds to list all of the files and generate the 1 million flow files. And if I see here, I can see that now the shuffling is active. So I'm shuffling all of those flow files across my NiFi nodes in my cluster, so that not all of the flow files are on the same node, the primary node, and then the fetch file will be used to actually retrieve the file. So actually, if I can already start the fetch file, I will start fetching files, and I can see here that I'm reaching 30,000 flow files instead of 10,000, because in this situation, all of my 3 nodes of my NiFi cluster are used to actually fetch the file. So if I list Q, I will see that I have data on all of my 3 nodes, NiFi 0, NiFi 1, NiFi 2, etc., etc. So in this case, I'm really leveraging all of the NiFi nodes of my cluster. But the big issue here, if you have a use case where you could be listing a very large number of files, well, as you can see, we are not taking into account the back pressure in this connection, and we will be generating a very large number of flow files, which is not great for the memory of NiFi. In this case, if I do the same here, as I said, I have a record writer. So well, actually, just to explain here, you can see that all of the flow files have empty content, so there is no content. However, if I look here, I can see that my flow files have attributes with the metadata of the file that has been listed. So the absolute path, the permission of the file size, the file name, things like that. So yeah, so that's what we want here. Here, if I list file and I start here, this is going to be different, because in this case, I'm just going to generate one single flow file in which I will have content, and the content will be an array of items containing the metadata of my listed files. So here the listing is going to be a bit faster. Then the split record is just going to decide, okay, I want to have up to 1,000 items, records per flow file. So remember here, I'm going to generate one flow file, here it is, that is containing the metadata of 1 million files. And I'm not going to open that flow file in my browser, because otherwise this is going to be really bad to show you the content. However, here I'm saying, so I have one flow file with 1 million let's say 1 million records describing the metadata of my files to download. Here I say that I want flow files with at most 1,000 records each. So if I start this is going to convert one flow file here into 1,000, each one containing metadata about 1,000 file. So if I list Q here, and in this time I can look at the actual content. So if I look at the content here and I display it correctly, I can see here that I have, I'm using JSON. So I have a JSON array, and each item is the metadata of the files that I'm listing. So with the path and the file name and so on and so on. So that's what we want, right? Next, the partition records is the processor that you can use to say, okay, look at the records in my flow file and create one flow file for each record where file name and path are different. So I want to partition based on file name and path. So effectively, in this use case, this is going to create one flow file per record, because obviously each combination of file name and path is different. So if I start this is going to take, I can run once. So it took one flow file here. Remember, the data is still on the primary node, right? All of this is still on the primary node because here it's on the primary node and I didn't use shuffling here or here. So right now, all of this is still on the primary node. So when I run partition record once, it's taking just one flow file, and here it did the partitioning. So now I have 1000 flow file. And if I look here, now the content of the flow file is, well, just an array with one item. But something that is interesting is that the partition record processor created two flow file attributes with the path and the file name based on what I specified in the partition record. So basically, the partition record is saying, please look at the records and create one flow file containing all of the records that are containing the same value for my partitioning values. So here, file name and path. And since all of the records within the flow file will have the same value for file name and path, you can add this information as flow file attributes. In this case, given the use case I have, the partitioning is effectively creating one flow file per listed file. So that's why I have 1000 flow file here, and that this is here I'm doing the shuffling across my NiFi node, so that's here again. The fetch file is actually running on all three nodes. So here, if I list skew here, we could see that I'm retrieving data across my three nodes of my NiFi cluster. So if I start this, this would effectively retrieve everything I want. So you have the three approaches, and a good question that you may be asking is, what is the most efficient? So I'm going to stop this here, and stop this here. I'm going to empty all queues here. So this is going to take a few seconds to delete all of the flow files, because there is a lot. Also, something important to keep in mind, a difference between GetFile and FetchFile. By default, FetchFile will not remove the file. GetFile by default would delete the source file, but in this case, the fetch file is not. However, you can configure the same if you want. Here, the completion strategy is none, but you could say after I retrieve the file in NiFi, I want to move it or I want to delete it. So it's something you can do if you want. Okay, so I will just here set an update attribute processor that is just doing nothing and auto-terminating the success relationship here, so that as soon as the data is retrieved in NiFi, I'm sending the data, removing the data, right? Okay, so I'm going to do this here. Stop this here, remove that, and here. So I have the two options, and we are going to see what is the most efficient way for this. Okay, so I'm going to stop this here. As I said, the list file is keeping some state about what has been listed during the last execution of the processor. So if you look at the state, we can see here what was the last information listed. Okay, I can clear the state, which means that when I start the processor again, it's just like I never listed anything. So I will be doing the same here. So that's a good way of saying, okay, let's start over, and I want to list everything again. Okay, so I will start this, and to be in a good scenario, I'm going to do this first and look at how long it takes to fetch the 1 million files across my NiFi cluster, and then I will do this. Okay, so let's start this one and wait for this to be completed. So I will pause the recording because we know that just the listing is taking a bit above 4 minutes. And I will start again the recording once the listing is done. Okay, so the listing was successful again with like a bit above 4 minutes. We have the shuffling of the flow file across the nodes. Fetch file is fetching the data, and then update attribute is just doing nothing. It's just to remove the flow file so that we don't have back pressure here. I could actually auto-terminate directly after the fetch file, but it's just for the demonstration here. So we see it's actually very fast to process all of the data. So 4 minutes and 10 seconds to do the full listing here. And then the actual fetching of the data. So we will wait a bit here, but obviously, if you increase the number of nodes and all of your nodes have access to the same storage, things would get faster, assuming that IOPS are okay with the storage you are attaching. That's always the same issue. If you are mounting some network storage, like network attached storage to your nodes, you need to keep in mind that performances may be bounded to the level of IOPS you can expect with this kind of storage. So in this case, I have 3 nodes, so it's perfectly fine, but you could not scale to an infinite number of NiFi nodes for linear improvements of the performances. So here we can see 4 minutes and 10 seconds for the listing, and we can see it will be about the same for the actual processing. I'm waiting for it to complete, but in the end, it sounds like the overall processing of listing and retrieving the files on NiFi will be about 10 minutes for 1 million flow files of 100 bytes each. So I'm going to wait until everything is done. But yeah, it will be about 5 minutes here, 4 minutes and 10 seconds here. So let's say about 10 minutes to do the listing and the retrieval of the files on the NiFi nodes. So really getting the flow files with the actual content of the file you want to process. So I will wait for this to be done completely, so that then I can start this part here. I'm actually wrong here because this is across the 3 nodes. So I'm actually wrong. This is the cumulated time for fetching the files across the 3 nodes. So actually here, if I look at status history and flow files in, and I go here, we can see it's actually more like well, 4 minutes, something like this. And we can see that's interesting, the shuffling across the node, because the NiFi 1 is the primary. The shuffling is done in a way that in the end, in the end, all of the nodes are processing the same amount of data, because remember that we are showing here like a 5-minute window, sliding 5-minute window. So in the end, all of the nodes process the same amount of flow files, but because of the shuffling, the nodes that are not primary process their file faster compared to the other one where active shuffling was happening. So in the end, if I go back here, flow files in, and I go here, so between this moment here, which is about, here and here, which is the end, it's actually about 5 minutes. So overall 10 minutes for everything. Now, if I do the same here, let's see how fast this is happening. It will be faster because the listing alone and generating the 1 million profiles took 4 minutes and 10 seconds alone. In this case here, the listing is done in 18 seconds, so it's really fast. And then here we can generate the splits very quickly here, and then the partitioning, and then the fetch file here. And I need to start this, otherwise so here we can see that all of what's happening before the fetch file actually took like 20 seconds, 18 seconds for listing, then splitting is 3 seconds, then the partitioning is taking some time, but we can do at the same time the partitioning and fetching the data across the nodes. So we'll see how long it's taking, but listing, splitting, and partitioning is almost something you can ignore, and you have almost only the partition, like the actual fetching of the data. While this is running, something that I want to show you is something I was mentioning with the list file here. The list file here that is running only on the primary node and generating 1 million flow file at the same time. If we go here in the node status history, we can see that it is impacting the heap significantly of the NiFi node. So we can see here NiFi 0 and NiFi 2, they are perfectly fine in terms of heap. NiFi 1 is my primary node, and we can see that it's putting a lot of pressure on the heap. So in this case, it's fine because NiFi is going to handle this perfectly fine. But if you have like a lot of use cases doing the same thing and holding into memory a lot of data like this, you could go into out of memory exceptions. So in this case, I have enough heap, so it's fine. But you can see that this could have bad results on your cluster, while the other nodes are perfectly fine and perfectly healthy. So NiFi 1 will get back to a perfectly healthy state, so it's fine. But the list file, listing a lot of files in one given iteration, is going to put a lot of pressure on the heap of NiFi. So if you do expect the possibility that ListFile or any ListX processor is going to list a very large amount of files in one iteration, please use this new feature that is giving you the option to specify a record writer. The flow definition is a bit more complex. Like, you have some additional processors to take it into account, but this is worth it if you are in the situation where you are potentially processing a lot of data. Not a lot of data in terms of how much content. Again, when I'm saying a lot of data, I'm really talking about a very large amount of files that you are going to list at in a single iteration of the list processor. Okay, so we can see that things are going fast here, so we need to just wait a bit more here, but this is being processed quite nicely here. We can see that I configured round robin balancing here as well. So round robin, so that the flow files are load balanced across my NiFi nodes, so that all of my nodes are actually fetching the data. So we are almost done here. And that's almost it. And that's it. I processed 1 million file. And here, if I look at view status history and flow files in, and I go here, we can see that it took a bit more than 5 minutes. So let's say 6 minutes, right? Okay, 6 minutes plus the 20 seconds initially for the listing. So it's almost, not exactly, but you could say it's almost twice faster to have this pattern to process the data when you are listing a crazy amount of flow files. Obviously, if you are just expecting just a few files to be created between 2 iterations of the list file processor, you are probably not willing to do something like this. But if you believe that your use case could be generating a lot of files that the list file processor is going to list in one iteration, then this is safer to have this approach with the record writer. Keep in mind that having a lot of files to list can happen also if your NiFi nodes are down for some time, for some reasons, maintenance, upgrades, whatever, and you are starting everything again, and the list file has to list a very large amount of files. So in that case, having this approach may be a good idea. That's it for me. I just really wanted to show you a few things around GetFile that you should never use, and then list and fetch file, and how to use this record writer option in the list file processor. Again, everything that I explained also applies to other processors like ListHDFS, List S3, List ADLS, List GCS, List Azure Blob Storage, List SFTP, etc., etc., etc. So this pattern, list fetch, is very common, and you should be aware of how things are working to make the right decisions when you are designing your flow. Thanks for watching, and well, see you next time. Thanks.